David Smith here with another Flip Classroom video. 3 tips before we start. First, remember you can pause the video anytime to catch up with your notes. Second, you can turn on the captions below so you can watch my words go by on the screen. And lastly, you can play the video at double speed if that helps you get through it faster. Today's video, Sine rule, the ambiguous case. I like this title. Ambiguous is a fancy schmancy word for not very clear. And this is one of those cases in mathematics where you get 2 answers and one is kind of hidden and you have to suss it out whenever you use a sine rule to find an angle. So check this out. Triangle ABC has angle B, 34 degrees. Little b, that means a side, 15 centimeters, and little c is 20 centimeters. So I've gone ahead and drawn that triangle here for you and marked the information that we know. Now what I want you to do is pause the video and use the sine rule to find angle C. That is this one up here. This problem is set up to find that. So go ahead, pause the video, find angle C. All right, let's see how you did. So what I did is I set up my ratio here using the sine rule, and I just have sine C equals the length of the opposite side over sine 34 equals the length of its opposite side. And you'll notice I put my sine function on the top of my 2 fractions. I can set them up either way as long as I do it the same on each side of the equal sign. I rearranged for sine C on one side alone, took the inverse sine of this expression here, which all these things are known, and what I get is 48.2 degrees for angle C. So we go ahead and mark that here, 48.2. So I found angle C. Now, here's the tough part. That's not the only possibility for angle C. There is another possibility that's entirely consistent with these 3 measurements, with our givens. So what I want you to do is pause the video real quick and just think about that. Maybe doodle on your diagram, maybe draw it again and see if you can draw another triangle, not with the 48.2, but with the 34, the 20, and the 15. See if you can make another triangle that's consistent with these 3 givens. All right, so I sketched that triangle in red inside here. And notice what I really just did is I took this 15 length side and I rotated it down until it connected with side A in the same place. So this is still 15, this is still 20, and this is still 34. But it's very much not the same triangle that we started with when we found 48.2, okay? So what is this angle C? Let's call this C prime. What would that be? Now the trick here, it's pretty straightforward. It's just gonna be 180 minus this number here. So check this out. All I gotta do is 180 minus 48.2. So go ahead and finish that calculation. So 180 minus 48.2 gives me 132 to 3 sig figs. So that is the other angle C. So here's the thing that's going on. When you do the inverse trig function to find an angle, it's always going to give you an angle between 0 and 90 degrees. That's the first angle that satisfies the equation. But there are other angles that would satisfy that. There are multiples. So in this case, 180 minus that first angle gives you the second angle that satisfies that function. Later in this class, when we get to the unit circle, you're going to see that there's an infinite number of angles that would satisfy this equation. So your calculator, when you run a trig function, is always going to give you the first quadrant solution, the angle that's between 0 and 90 degrees. So your critical thinking step is to look at the problem and decide whether or not you got the correct angle. All right, so now what I want you to do is draw these 2 triangles separately and find all the angles in each one. Let's just make sure they all add up to 180 degrees and so on and so forth. So do that. All right, let's see how you did. I went ahead and characterized everything about these 2 triangles. So first, here's the triangle that we started with. I got 97.8 for angle A. Remember, that one was not specified by the problem. I just found it by subtracting these 2 from 180. And then I use my sine rule to find my third side, my little a side. Now, this makes sense. If that's 20 and that's 15, I could see this one being 26.6. It's in the right ballpark. Maybe my triangle's not quite right to scale, but it's close enough, and I can tell that this makes sense. This triangle works. I've got 180 degrees inside, and my sides are roughly the right lengths for how I've drawn that. Now, if we scoot over here, I've taken this little red triangle and drawn it alone by itself. Then done the same thing. I subtracted these two from 180 to get 14 for angle A. So instead of 97.8, now it's 14. But that's okay because it wasn't specified by our problem. Remember, our problem only gave us one angle, and that was angle B. So angle B is still 34, so we haven't violated that. Now here is our obtuse angle for angle C, and that's 132. Now all those add up to 180, so that works. Then finally I use the sine rule to find the side length for little a, and that ends up being 6.51 with that math there. Now that makes sense also. If this is pinched down here, we've got 15 and 20, that, yeah, 6.51, again, in the right ballpark. So here it is. Two triangles are consistent with this instruction. So you might get a tricky problem that might say, triangle ABC has this information. Draw all the possible triangles. And you'd have to recognize that this is the one you would get right off the bat with your calculator, but you'd have to realize that there's another one with an obtuse angle C that also works. So let's generalize a little bit. I've redrawn that triangle and I've just marked theta there. So that was the angle that was 34 degrees. Now we're going to back up. We're not going to say what it is, but we're going to say some things here. So when theta is acute, and that's the thing, when this problem rolls up, if you start with an acute angle, you have to be wary for the ambiguous case for two possible triangles. So there's something you can say about sine theta. So when theta is acute, sine theta equals something else. Now you might peel back through your notes so far, take a look and pause the video and do some critical thinking here and see if you can write another expression for that. Okay, so if you looked back, you probably noticed that sine theta is going to also be sine of 180 minus theta. They give you the same thing. So go ahead and test that with any theta that you want. Pick a theta that's acute, so less than 90, put that in your calculator, and then do 180 minus that theta and take a look at what you get. All right, so I used 26 for my theta, and I did sine 26, that's 0.438, okay, pretty cool. Now I did sine 180 minus 26, which is sine 154, and I got 0.438 again. So that's fine, and it doesn't get in the way if you're using the sine function to find side lengths. But when you go backwards to find angles, it's always going to revert to 26. So if you did sine inverse of 0.438, you're going to get 26. But if your angle in actuality was 154, your calculator's not going to show that to you. So one way to tell what's going on, if you have an obtuse angle on your diagram, if that angle is obviously greater than 90 degrees, you solve for it and you get an acute answer, then you know you need to subtract that answer from 180 to get the true measure of that angle. So what you need to look out for is when you're finding angles with a sine function, look for the ambiguous case. Do that critical thinking set. Make sure that your answer is right. All right, let's do an IB problem. Here's my diagram, here's my sketch, and here's the prompt. Find angle A. So go ahead, pause the video, and just attack this with the sine rule and see what you get. Okay, let's see how you did. So here's my equation set up. I've got my sine functions on top on both sides. I realize that way I can just multiply up with my 135, and my sine A is in the right spot. It's on top of the fraction. And then I rearranged everything. Angle A is sine inverse of all of that. And I get 37.2. So hopefully that's what you got, and good job on that problem. Aha, now hopefully you were saying, wait David, but, because there is a but. Now, if you don't see it, pause the video right now and figure out why this is not a full points answer. Okay, check it out. Is that angle 37.2 degrees? No way. That is an obtuse angle. So what we did is we did use the sine function inverse to find an angle, and it found us that first quadrant angle like it always is going to do. So this is the ambiguous case. In this case, we got the answer that's not the answer for our angle. So pause the video and find the correct angle. All right, so what you have to do is you have to subtract the acute angle that you found using the inverse sine function from 180, and that gives you the measure of this obtuse angle A. Okay, so you've got to remember that. This is all a critical thinking step. There's nothing wrong with the math that led us to 37.2. That's a perfectly great calculation. In fact, it's necessary to finish the problem. But indeed, we have to finish the problem. So there's two possible angles that come out of this equation with the sine function. You have to interpret your results to figure out which of those two possible angles is the one that you need. Now, I want to give you one last step. On this diagram, or as a new triangle, I want you to sketch the triangle that has the acute angle for angle A. So go ahead, pause the video and do that. All right, here we go. I did it on the diagram. So this red triangle has all the same features as our original triangle. It's got the 135, this side is 135. It's got the 21-degree angle here, and this 80-degree side has just rotated over here, 80-meter side has rotated here, so it's still 80 meters. So this red triangle still fits the same of the initial measures that we were given, but instead of 142 for our obtuse angle, it's got our 37.2, 142.8. It's got our 37.2 angle up here for our A prime. So that's the second triangle that could be described with that equation. All right, here's an IB type question that you might see where you'll need to use this ambiguous case idea. So we've drawn a triangle here, and we're giving you some information. Two sides are here. We know the area, and we want to find the measure of angle B. Okay, so technically, this is a triangle area formula problem, but we end up with the same situation using the sine function. So let's do that. So here it is. Find all the possible angles for B. So right here in the prompt, you should be thinking, okay, I'm going to solve this, I'm going to get an answer, and then I'm going to need to think about if that's the only possible answer. And that prompt is suggesting that maybe there's more than one answer. So given that we have the area of this triangle and we're asked to find an angle, you should know that you need to use the triangle area formula to answer this question. So go ahead and pause the video and do that. All right, so here's my plug-in step with the triangle area formula. I rearranged it all in one step so that I could take the sine inverse of the rearrangement here, and I get that's angle B, which is 59.6 degrees. So woohoo, I got my angle. Now, your critical thinking step when you finish a problem, even if it didn't say find all possible values, should be look back at your diagram and make sure that this makes sense. And if I do that, that angle doesn't look like a 59-degree angle. That angle is obtuse. It's bigger than 90. That's not bigger than 90. So we have an issue here. First step, I would just check my work, make sure I did that right. And if you do that, you'll find out that that is good. So now I'm thinking, okay, maybe I have this ambiguous case. The sine function gave me an angle that's acute. Maybe the angle I'm after is really obtuse. And that is indeed the issue here. So go ahead and pause the video and find the other possible measure of angle B. All right, so if I subtract 59.6 from 180, I get 120.4 degrees. So in this diagram, that would be the correct answer for angle B. It's clearly not 59 degrees. So if I just said, according to the diagram there, use the information to find angle B, you would have to go with that answer. This one would not be full points because it's obviously not the correct one for the diagram. I forget how I start that. Does it go?
Here, I
That's
hope
all
the
for
video was
today.
helpful. I can
What?
put an
Now that you've watched the video, write down any questions you still have so you can remember to ask them in class next time we meet. Also note that you can watch the video again if you want to deepen your understanding or patch up any gaps. Finally, give me a like and subscribe if you enjoyed it.
Yeah!